Hey everyone, welcome back to another OSCP Journey video. Today's video is probably going to be similar to the last one, not sure. We're doing another SQL to Shell from the Pentester Labs. This one is the SQL to Shell Postgres edition. I'm doing this first instead of doing SQL to Shell 2 because I feel like this one's going to be very similar to the original. And I believe SQL to Shell 2 is blind SQL injection, so that's going to take things a step up. So before we move up, I want to complete everything kind of beforehand, as kind of like a level thing. So complete the two ones that come before. That just makes sense. But anyway, so this video today may be pretty short. We'll see. I'm not sure exactly what's going to be different, what's going to be the same between the Postgres edition and the regular edition, but we will find out. So let's get started. So I have already gone ahead and pre-set up a little environment for myself to run scans and whatnot. So let's do another. Let's go ahead and open the TMX session. SQL Shell. All right. So we'll run another .dat discover to find our new host. All right. Here we are. Now we'll run an in-map scan. So we want to say default scripts, enumerate service versions, take the operating system, all formats to in-map, SQL to Shell. I'll also do some fun things like maybe try some default creds and stuff after some time. Just to see how similar these machines are. I feel like they're probably going to be exactly the same. It's just that the backend is Postgres rather than MySQL. So the real difference here is going to be how we structure queries. 90% of the syntax is going to be the same. We just won't be able to do the sleep to test for the SQL injection. I believe we'll have to do something else. But for the most part, I feel like it should be very, very similar, if not exactly the same. We will find out. Alright, so visit that webpage. We're back here at the good old awesome photo blog. We're not going to do a whole lot of enumerating. We're going to kind of just hit the ground running. So ID equals 2. Let's see. Before we did a union select null. I believe it was 4 nulls. Yep, that was it. And if we do like sleep, just sleep for 5 seconds, if I can type, that's not going to work because Postgres, I believe, is something different. So let's see, sleep in Postgres. And we really wouldn't even know this is Postgres if it weren't for the title of this challenge. But this would be an example of what I was talking about in the last video. I can use the delay and sleep functions to kind of get a good guess on what exact database we're using on the back end. If it's a T-SQL database or something using like Microsoft SQL Server and stuff like that, the command will be wait for delay and then some kind of time string, and if that works and executes successfully, that means that the backend is more than likely a T-SQL or Microsoft SQL Server. If it's a sleep function, it's probably some kind of MariaDB MySQL kind of deal, and if neither of those work, you can try the Postgres sleep function, see if it's Postgres database, and so on and so forth for all the different database types. But those are probably all you'll really see for the most part. So even though we know this is Postgres on the back end, we could confirm that by kind of enumerating through all the sleep functions. So we know sleep didn't work, so it's not MySQL anymore. PG sleep. Now we're getting some kind of like syntax errors. So let's see. So you got a PG exec, query failed, union, carry. Void types cannot be matched. So maybe we do it first. Might have to do a little bit more research on this. let's see. So we know that if we did like all nulls, that worked. And if we say user, get a syntax error. Okay, so maybe we can't go about this exactly the same way. Maybe Postgres does things different. So union select Postgres. That should be the same for the most part. I wouldn't think this would be any different. I'm not like a SQL expert, but you know. Let's look at that error a little bit closer. Error syntax and error. Pictures. Okay. It's giving us some more info. So one select start from pictures, or cat equals 2. You select. Okay. So we can say union select. Try saying password from users. Okay, so our same SQL injection from before works, but that's only because we knew the schema. We need to figure out a way to get schema back. So select maybe here's an interesting thing we may be able to try. You can say select nested select statement, maybe. Yeah, like a subquery. Yeah, this is what we want. This is exactly what we want. So we want to say information schema Postgres. So start from, yeah, that's what we want. And we want to run some subqueries, so we want to do it like that. So we may have some issues because it's not looking like it's liking our like parentheses and such, but we will see. Okay, so let's see. PG sleep 1. Alright, Postgres sleep function. I just want to kind of validate that it is Postgres further on the back end other than through the error message. I also want to just see if I can get these functions to execute, and I also want to try to bypass that parenthesis issue. PG, so we know this isn't a PG exec. Use parentheses. Let's go look here. We don't care about the PG escape string. Using parentheses. Let's try this. rather than going right straight for the union select, maybe say like an or an and select PG sleep 2. Okay, so here's our query. Select star from pictures where cat is 2. So we're getting a lot better feedback than we did originally. Let's see. One from pictures where K was 2. And just sleep, maybe. Sleep Postgres. I don't care about returning values. Because we're not must be Boolean type. Okay, so we're getting like some fundamental errors here, but if we say union select and we say null, 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 big int cannot be void. Say 4 nulls here, we don't have an issue. Okay, let's Google this error. Message. In the context of PG sleep. Alright, maybe union types big int and void cannot be matched. So let's try 1, 1, 1. Maybe we just fill it up with PG sleeps then. Okay. Well, we can still confirm that this works like before. And we just want to select some data from information schema tables. So I want to say tables. Let's see. Oops. Information schema Postgres table schema. That's right. So we want to say table schema. Okay, there you go. So do like we did before with columns. We want to select column schema maybe, or column. I'm not real sure. Information schema columns. Column name. Alright, cool. So now we have the same stuff we had before. So we got this pass WD. It's probably in somewhere else. So this is basically the exact same challenge, it looks like, as before, which is kind of boring, but it's interesting because it is Postgres. So we weren't able to actually do the the same checks we were before. We had to kind of basically go straight to the blind injection. So we know, since we have our schema, we know that we can dump password from users, and we can also dump, I wonder if I can do some cool, like concat I don't know what it would be. Maybe username, user, yeah. So Pentester Lab is the new user, and the password. So let's just verify that where user equals Pentester Lab, maybe. No, because we need like quotes and such. It's gonna be a pain having to work around that. I don't think we'll be able to. Okay, yeah. All right, cool. So that worked out great. Kind of verified that. All right. Let's see if we can crack this password again. I think this is probably the same password. We'll see. MD5 password crack. We already know this is MD5 hash from the last video. Just pop it into good old crack station and crack it. See what happens. It's a good thing we did check the schema though, because it's a different username. So password is our password again, and we go to Pentester Lab. No? Admin? No, still admin. That's weird. Not sure why that happened. And then from here we go about things kind of the same way. I'll do it just for the sake of doing it. So let's go ahead and make ourselves a new shell. So we want to call this nano shell.php. Look at me being a lame-o using nano just for the quick and dirty. Always use them, kids. Never try this at home. Alright, so we're going to say command equals $request command, and we'll say system command. Got a little shell real quick. Add that in. We know to go to uploads, so shell.php, cmd equals ls. Alright. Who am I? Always check for that. And we don't know everything about this box, but we can assume that we still have netcat, and we do. Let's go ahead and pop shell. So we'll say netcat lvnp 1337. First, let's figure out what my IP is. It's always 186 on this labnet. Alright, so ncat-lvnp 1337. Start listening. And we will connect back. Send us bin bash. Alright, cool, that's good to go. And then from here we can try to maybe prevesc from with a different exploit maybe. Last time we did dirty cow. This time maybe we can try something else. Might be fun to play around with, we'll see. So we'll say search exploit Linux 2.6 priv. So we've got a couple things. So we're dealing with specifically 2.6.32. So we got a Ubuntu issue, got a CentOS issue, got this pipe. We tried this one last time. Don't understand it well enough to actually make use of it. Not even sure if it'll work. Dirty cow's always good. 2.6.esc. Here's that pipe C prevesc with some C code. You can take a look at that. See how it works compared to that shell script. Alright, so alright, this seems more promising. We can try this one out just to get some experience using another exploit. So this is this pipe C exploit. Let's copy the path. So we'll say copy to here. And we want to compile that for this system. So we say gcc pipe C-M32. Got some warnings. Should be okay. If not, we will have to cry about that later. So we'll say move out to pipe. Call it pipe exploit. And we'll start up a Python simple HP server for 80. So we get HP 2.6.8.2.186 pipe exploit. Alright. We'll say not sure if that worked or not. We didn't get any errors, but we also aren't getting much output in general. We're still www data. Maybe if we say pipe exploit and cut out any issues to pipe the output to a file. We'll redirect the output to test, maybe. Cat test. Nothing. Alright. It just might be that this isn't vulnerable to it. It might be something to do with those errors. Not really too hung up on it. Let's remove pipe. Anything pipe, because we don't need that. Alright, so let's try. And we'll just do dirty cow again, just to finish it off. We can't not root the machine. We gotta do our due diligence. So let's just go ahead and put it out of its misery. Okay, so copy that to dirty C plus dirty.c. Let's have some fun with it though. Let's change some stuff around. Kind of be more sneaky. So we want to change salt is fine. It's not really all that important. What we do want to change is our username. We want to remain as root. User info root. And all that's good. Cool. Didn't really change a whole lot, just didn't want to be Firefart this time. Keep it a little bit more professional, so to speak. So tack on 32-bit compiler flag. It's compiled and ready to go. Let's start up our HTTP server. And we get HTTP :/192.168.2.186.30. And so we'll run dirty, and our new password will be rooted again. Okay, so this is going to take a second. I'm actually going to let it run its course, do due diligence before I try to log in anything, just so I don't break anything. Yeah, so this video, not as great, but I'm glad I did it just to do it. Kind of affirms what I did last time. It was a good practice again. A little bit disappointed that there wasn't more to this machine. It was literally the same machine again, but no big deal. This is a really good machine. I do like it a lot. Hopefully the next one will be more of me beating my head against the wall. I'm sure it will be, because blind SQL injection is a whole monster of its own, and I'm doing this without SQL map, since SQL map is not allowed for use on the OSCP, so it's going to be a lot of me writing some new scripts that hopefully will help me out on the OSCP later, so might as well do it now. Alright, so looks like the script is still running. Give it a little bit more time. Go ahead and open another sh app. Okay, there we go. So it looks like everything completed successfully. So we've got everything's good to go. Cool. So we have our shell still here as the www-data user. Obviously we can't get into root. It's not going to let us. But we should be able to SSH in as root over here with our new password. And there we go. We are rooted. This time we are root instead of Firefart, just because we tweaked the exploit script a little bit, changed the name. That's all there is to this box. Not much more to go off of. Next time I'll do the SQLi to Shell 2 from the Pentester Labs, and that'll be a little bit more exciting. So thanks for watching. I appreciate all the support I've been getting. I notice a lot of people are subscribing. This is really neat. For this is really just my journey trying to obtain my certification. So it's really interesting that there are people who are interested in watching this, be it for entertainment or for learning. That's just kind of cool. So thanks, and feel free to keep leaving advice, feedback, and just overall good comments in the comment section. Stuff like, subscribe, all that good stuff. I'll put out another video soon. Thanks for watching. Why waste time?